right, hello everyone. My name is Timothy Lee Grant, and we are going to be doing another leak coding video, another one. And as always, we are doing heaps. Well, not as always, but we're focusing on heaps. We're going to get good at heaps, and then we're going to move on to the next topic. So, right now we're doing heaps. We were doing depth first search. So, let's randomize it, and we're going to pick a medium this time. So, let's see if we can do it. So, close my eyes and pick the closest medium, which it looks like we are doing furthest building you can reach. All right, so let's do it. 1642. Furthest building you can. Oh! And it has an animation. I've never seen Leetcode have an animation before. Oh my goodness, look at that. Whew. I like that. Cool. Moving up in this world, eh? All right. You are given an integer array heights representing the heights of buildings, some bricks and some ladders. You start your journey from building 0 and move to the next building by possibly using bricks or ladders. While moving from building I to building I plus 1, 0 indexed, if the current building height is greater than or equal to the next building's height, you do not need to use a ladder or brick. If the current building's height is less than the next building's height, you can either use one ladder or the number of bricks, so the height difference, that number of bricks, okay? Return the furthest building index you can reach if you use the given ladders and bricks optimally. Okay, so I know when I'm looking for heaps, I need to keep my eye out for the keyword, which is like K most or K lowest, K smallest, K lowest, K most, K biggest, any of that, and it should trigger, oh, this is heaps. Once again, I'm not seeing anything here to really indicate anything to do with heaps. This seems honestly more like a backtracking problem where I need to try to figure out an optimal strategy. Huh. Okay. So then it just shows like with this, you have heights, which there's a building of 4, a building of 2, 7, 6, 9, 14, and 12. So you have 5 bricks and 1 ladder. So you can use 2 bricks to get to the second one, right? Go to building 1 without using... Okay, starting at building 0, you can follow these steps. Go to building 1 without using ladder, nor bricks since 4 is less than 2. Okay, so you can go down, no problem. Okay, go to building 2 using 5 bricks. Go to building 2 using 5 bricks. Yeah, that makes sense. You must use either bricks or ladders because 2 is greater than 7. Go to building 3 without using the ladder. Okay. Go to building 4 using your ladder. Okay. I'm starting to try to think of methods that we might be able to use. So what I'm thinking is I have this heights, which is all of the buildings. My ladder, I think, can go up an infinite amount. So if your current building height is less than the next building's height, you can use one ladder. So it doesn't matter if the building is extremely tall, and I'm way down here, I my ladder can cover the entire distance. So I don't want to use 1,000 bricks for that tall building. I just want to use one ladder. So I should use my ladder optimally, which means on the largest buildings. Okay. Now, there's another thing that's kind of throwing a problem in this, which is if I have this index here, and let's say that this was 2 right here. This was a 2. And so 2 to 12, that's a difference of 10. So my, like, I would say, oh, well, I should use my ladder here. But actually, what if we get stopped at this building and we don't even get to this, like, height difference? So we have to take into consideration we want to use our ladder optimally, but only within the subset of the list which actually we are reachable. But then that optimally depends on itself. So it's like it it's oh, it's raining really hard outside. Um so it depends on itself, and therefore it's changing in situ, right? So how would this work? This really feels like a backtracking problem. So I have no idea. Let's I guess we just write something. Let's try to I forget how to what should I do? I don't know. Def backtrack. I don't know why all of these heap problems. I've every time that I've done a medium on the heap problems, there's been nothing to do with heaps. They're all some other thing. Like the last medium that I did was about Dijkstra's algorithm, and it was like I haven't been studying Dijkstra's algorithm. How am I supposed to know? So now this one, I don't know if it's backtracking, but it sure looks like a backtracking problem, and it sure doesn't seem like a heap. Okay, backtrack. Index? Man, I have no idea. I know backtracking was something to do with recursion, so we need a base case. Uh, See, at this point, I can't tell if I'm just really, really bad at Leetcode and bad at, like, programming, or if it's just because I can't recall specifically how to do backtracking. So it's kind of that question like, okay, well, what if I get asked a question similar to this, and then I just freeze up, I can't do it, and then they throw me away, right? Like, uh, hmm. Because I am completely drawing a blank on how I might want to accomplish this. Backtrack. So the way that I'm going to move forward with this is I'm going to guess that we're not going to be able to solve this problem, but the important part is there's two things that I want to accomplish with this problem, even though right now I don't think we're able to do it. The first thing is, okay, struggling is actually a good thing. If I struggle with backtracking a little bit, try to figure out backtracking myself right now, okay, when I try to learn it in the future, it's going to be much easier for me because I've already struggled with it. This is one of the things that I definitely think is extremely important, which is not to just look at something and not struggle with it, not wrestle with it. Because if you don't struggle, if you don't wrestle with the topic, then you're not going to get a deeper understanding of the topic. So that's kind of what I want to do right now. We're not going to be wasting our time. We're going to be attempting to do backtracking. We're probably not going to be able to do it because just we're not geniuses, right? Or at least I'm not a genius. Maybe you are. Maybe you are. But I don't think I'm going to be able to pull backtracking out just randomly. Then once we struggle with this problem for a little bit, we're going to go to Copilot and we're going to ask it for the solution, and then we're going to do the autopsy of this problem. So figuring out what went wrong, what were the concepts that we missed out on, how can we improve and make it better for next time. So let's try backtracking. I know that we need a base case, so it's something to do with the if we reach the end of these heights. So if okay, so heights length equals length of heights. Okay, so if index is greater than or equal to heights length. Okay, what do we want to do in this case? Backtrack. We want to return, but do we want to return any number? That's what I remember something of backtracking was like sticky, and this is the way that I kind of like conceptualized it. You had some like sticky value that as you do the backtracking, it would change while you're doing it. And so that's why I called it like sticky, but I can't remember. Maybe like what if I did something like furthest index equals 0. So this is like the furthest index that I've ever seen. Okay, so what I think I might do is something like this. I'm going to have this backtracking, and I'm going to try to use a ladder on each step. So from here to here, I'm going to try to use a ladder, and then I'm right here. Okay, cool. Now I'm going to go from here to here, and I'm going to try to use a ladder. Then I'm going to go from here to here and try to use a ladder. And then, I ran out of ladders. So I'm not going to be able to do this to use a ladder. So I'm going to use bricks to use a ladder. So what I'm going to do is oh my goodness. I think it's hailing now. So anyways, what I'm thinking about doing is just keeping track of the current index that I'm at. And I'm going to try like all combinations. So I'm going to try ladder, 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 ladder. And then once I don't have any ladders, I'm going to try brick, 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 right? And then I'm going to do a backtrack back and use my ladders, right? So maybe I don't know if I can explain this right, but then I'm gonna see like I'm gonna update furthest index, only if my current index is larger than my furthest index. So that means that I've made one step forward that I previously haven't. So something like if current bricks and not So if not current bricks and not current ladders. So I also need to keep track of that. So current bricks, current ladders. So I'm going to be using bricks and I'm going to be using ladders. Okay, so if I don't have any bricks or ladders, I just want to return. Now, I want to try to use a ladder. So if current ladders, then I will backtrack index +1. So I'm moving to the next building. Okay. And then I am current bricks. So current bricks is going to be the same, but current ladders is going to be subtracted by 1. So what I'm doing is I'm going to be traversing to the next building. I'm not using any bricks, but I am using 1 ladder. And then I'm going to go to the next building, right, up here, and see if I hit my base case. If not, I'm going to keep doing this until I don't have any ladders left. So if current bricks, then I'm going to do the exact same thing but use a brick. So backtrack index +1 current bricks -1 and then cur ladders. Okay. And then somewhere in here I do need to increment the I need to update this like furthest index. So I'm gonna do like non-local furthest index. Okay. Now if index is greater than or equal to, I guess it doesn't matter about equal to, greater than furthest index, then we want to update furthest index. Index equals index. Okay. And then just backtrack on, we're going to start at the 0th index, then current bricks is going to be bricks, and then so with a D? Yeah, it is D. LADDERS. Like this. So we're backtracking. Okay. And then we can just return furthest index. So that's what I'm thinking would be a solution. Backtrack current bricks. So apparently this is misspelled. Okay, so this is what I think the solution should look like, but wrong answer, but obviously not. Okay, cool. So let's yeah, I'm not gonna be able to solve this problem. And I think that the best way to make sure that we don't waste our time, don't waste our energy, is just go straight to. Oh, and by the way, this is from. I also make videos where I practice doing like JavaScript and Java. So this was yesterday's video. We were making this kind of web application, and I had my server here on Visual Studio. So I created this Node.js or Express, and we've been communicating with it. So that's this guy right here. But anyways, we're looking for Copilot. Now, here is my answer. Then I'm going to copy and paste my answer. So let's see what it says. Your backtracking approach is Oh, okay. Maybe maybe we weren't supposed to use backtracking because it says interesting, and I don't know if generative AI uses the word interesting the same way as normal like English speakers do, where we say it's interesting. It's like that. I don't know if that's what this Gen AI actually means by interesting. Like creative. It's creative, but let's try something better. Kind of like that. Uh, but it might be too slow for larger inputs due to exponential nature of backtracking. Instead, we can use a more efficient approach with a min heap. Okay, so apparently you can use a min heap. I am going to be very interested to see how this utilizes a min heap because I couldn't see it. And that's also a really good thing that we came across is apparently you can use a min heap in this. So this indicates to me that there is a type of problem that I do not recognize that a heap is able to solve. So I need to realize and look at this problem and figure out like, okay, what class of problem is this and how can I recognize this class of problem next time as something that a heap is a useful tool for? Okay, so to keep track of the largest jumps where the ladder can be used, therefore optimizing the usage of bricks. But I understand that you can get I just don't understand how it's something that you can do with dynamically. Okay, anyways. I keep looking at the sunset out there. It's just beautiful. It's just like Oregon clouds in the fall and winter time are just top notch. Anyways, let's not get distracted by the beauty of nature. No, we have Leetcode that we need to be doing. We need to be on our grind. Come on, man. I just want to have a fun life. I want to have a good life. Anyways. I eventually we'll escape out of poverty, right? Eventually. Okay. Uh no nature until you've gotten out of poverty. None. Let's keep on our grind. Okay. Min heap. Use a min heap to track the largest jumps where we might want to use ladders. Okay. Bricks and ladders. If we can't climb bricks alone, we use ladders for the largest jumps stored in the heap and use bricks for the smaller jumps. Okay. So first thing that I'm gonna do, because I don't want to waste my time and energy, I'm just gonna see, like, does this even work? Like, is this submittable? And I don't think I need the import, actually. I think it just auto imports it. So let's see if it works. Okay, so it does work. So this solution is valid, but now we need to figure out, like, what on earth is going on and why. Okay, so we have an empty list, which is going to become our heap. Okay, so for I in range, so we're iterating through each of the indexes in this height. Okay. Okay, so what each iteration we're doing what? So we're finding the difference in height between the next building and the current building. Okay, that makes sense. If the height is 0, or if the difference is greater than 0, we will push that difference onto the heap. If the length of heap is greater than ladders, bricks minus equals heap pop. If bricks is less, what? What? What is going on here? Alright, so if the difference in height is greater than 0, then we want to push that difference, it's just going to be an integer, onto the heap. Okay, so now if if the heap has a length which is larger than the number of ladders that we have, but this is dynamic, all of this is dynamically changing, right? Then what do? We subtract bricks by the difference of the smallest. If bricks are less than 0, we would just return that index. Return I. Length of heights, which is length of heights. I don't even see how we're changing the length of height. Are we popping anything from heights? We're not even changing heights. How is that? Do you guys see that? Like, what? Wait, what is going on? Heights is modified nowhere. I have heights here, but I'm just indexing it. I'm not modifying it. I have heights here, I'm not indexing it. I'm just getting the length of heights, and this is what's passed in. I'm not modifying heights anywhere, but I just get the length of it in -1. What? Track the largest difference jump using min heap. This ensures we use ladders for the largest jumps. I, bricks, deduct bricks for smaller jumps when the heap size exceeds the number of ladder. But we're doing that each iteration. Like, doesn't that automatically mean that we use a ladder immediately? Because if we have 3 ladders and I get a distance that is positive, or a difference that is positive, then we're going to have 5 ladders and 1 value in the heap, right? And so this is going to be 1, this is going to be 5, so we don't do this one. So difference is greater than, so we push 5, or sorry, we push, I don't know what the distance is, it doesn't matter, like 3, we've pushed 3, whatever, here, and then, are we even modifying ladder? Like, we're not modifying ladder. So how does it subtract ladder? This is like this is a what? Deduct bricks for this method ensures that we use resources optimally. Yo, I don't understand this problem at all. This doesn't make any sense. We're not modifying ladder. We don't subtract ladders. We just throw that up in the air. We just say if it's less than the length of ladders, which doesn't make any sense. Then we say length of heap for some reason. And then, like, I don't understand. Here, what's the part that I don't understand? That entire thing. Like, the only thing that I understand really are like those 2 lines. There we go. Actually, well, I don't understand this whole thing. The only thing that I understand are like those 2 lines. This doesn't make any sense at all. Like, at all. Maybe we're gonna stay in poverty. Okay. Darn. Okay. Well, there's that, I guess. I don't know. I can't even figure out that there's not a chance I would have been able to come up with this by myself. Now I'm given the answer and I can't even I can't even understand the answer. So it's like they're not looking good for me, honestly. Honestly, let's kind of keep it real right now. This is not looking good for me. Yeah, but I'm sure if I just keep doing like Leetcode every single day, eventually something's gonna break, right? Like eventually I'll make it. No? Okay. But anyways, so there's that thought. Um yeah, so essentially trying to move forward, how, like, on a more serious note, like, okay, the joking aside, how am I going to actually learn from this experience and move forward. So this is one of those problems I'm going to keep track of, which is one that I was not able to solve, and I'm going to have to revisit it. So I'm going to make another video later on revisiting this problem. But before I do that, I'm going to study this solution, try to understand what's going on, try to figure out. Maybe if I'm just going to see, can you explain why this code works and go through some examples? Okay. The goal is to move from building 0 to the furthest building possible using a combination of bricks and ladders efficiently. The code uses a min heap priority queue to keep track of the largest jumps between buildings, which we might want to use ladders for. Okay. Heap usage. The min heap is used to store positive height differences. Yes, that makes sense. And I also know when we do the pop, we will get the smallest value, which kind of makes sense if we want to use bricks on the smallest ones. That's kind of what I was saying there. But it seems like it will change based off of, okay, if the next building is really tall, don't I want to use a ladder for the upcoming one? So I need to kind of have information on future events, which this I index is the only future event is I plus 1 here, but that's not taking into account multiple future events, which is why I thought we needed backtracking. Optimal resource allocation. For each building, if the height difference is greater than 0, we push onto the heap. If the heap size exceeds the number of ladders available, it means we have more jumps than ladders. Therefore, we pop the smallest difference from the heap and use bricks to cover the smallest distance. Oh, I think we keep doing this until we run out of either bricks or ladders or successfully. Okay, so I think I see what's going on. So what we're doing is we're just we're taking this first height. We're taking this like first jump, like from this building, the 0th building to the first building. We're taking that height, and if it's 0, we're just going to the next index. So now I is 1, and we're looking at this. So it's from building 1 to building 2. So this difference is 5 right here. So now the difference is greater than 0. So we push 5 onto the heap. Okay, cool. Now what we want to do is we want to keep going until we have the number of ladders. Like, let's say we have 3 ladders. So we want to keep going until we use 3 ladders. So let's say we come here and we've used 3 ladders. Okay, so we're at building 6, we're trying to go to building 9. Now, what do I want to do? I want to actually look at this thing here. So supposedly I've used all my ladders here. Now I want to kind of say like, okay, well, let's be a little bit more strategic. Which ladder do I actually want to, or which building do I want to use it on? So far I've pushed like 5 onto the stack because this was a positive difference, and I didn't push this onto the stack. So maybe this isn't a good example, but my stack contains those differences that I have used a ladder on. If I'm all out of ladders, I then say, okay, well, based off of all of the ones that I've been to, which strategically should I have used a brick for? So I take the smallest one and put bricks there to build up that, and now I have a ladder again, right? So I'm able to use my ladder as long as the bricks covered that are able to cover that distance. That's kind of what this is going. So if I'm out of bricks, I just return the index that I'm at. And so this is actually how it's doing the return call, is it's just returning the index. Now, the other case is if we break out of this for loop, that means that we've actually been through all of the indexes in that heights. So then we just return the this static number, which it is a static number. Normally, we're going to return this index because we're going to get the situation where we've ran out of ladders and we've ran out of bricks. If both cases are, if we don't run out of ladders or bricks, well, then we would just return the entire length of it. Okay, so now this solution does definitely make a lot more sense. What I'm going to do is continue, I'm going to keep track of this problem, and we're going to revisit it. We're going to use the learn and forget method. We're going to say, all right, we were unable to solve it this time. We saw the solution. Then we're going to leave it alone for a little while, then come back to it and try to resolve it back when our brains are kind of like have forgotten it, but it should still be in our subconscious. And then by doing that, it'll bring it out into our subconscious, or superconscious, or I don't know what the word would be. But anyways, it is going to bring it into our conscious. There we go. I think it's just okay. Bring it into our conscious awareness, and then if we see a problem similar to this in the future, we should be able to kind of more easily fix it or solve it. I mean, anyways, thank you guys so much for watching this video. If you liked it, subscribe to this channel. That would be amazing. We're going to revisit this one, and we are going to continue to do Leetcoding videos every single day until I get good at it. Keep doing it, keep doing it, keep doing it, not giving up, moving forward, moving forward, moving forward. Anyways, thank you for watching this video. My name is Timothy Lee Grant, and I will see you tomorrow.